Now students, we have already discussed the principle of moments, which is the anti-clockwise moment is going to be equal to the clockwise moment. Now we have to study how to apply these formulas, this concept into numericals. Consider this first case. There are two children of mass 30 kg and 60 kg. They are sitting on a seesaw at distance 2 meters and 2.5 meters. Now the question states, where should be a man of mass 75 kg should sit on the other side to balance the weight of these two children. So see, what we have from the principle of moment is what? The clockwise moment is equal to anti-clockwise moment. So whatever distance this man is sitting from the wedge, let us say this is x, so 75 times that x, because see, what is the formula of principle of moment? Anti-clockwise moment is equal to clockwise moment. What is moment? Force into perpendicular distance. What is the force? Force is the weight of this body. Weight is what? 75, this is mass, into acceleration due to gravity, g into distance, right? So mg into distance, but g is actually going to cancel out from both the ends, so that is why I am not even considering g here. So it will be 30 is at 2 meters, whereas 60 is at 2.5 meters. Now this whole thing is multiplied by g, and on the same thing this is also multiplied by g, acceleration due to gravity. That is why the whole thing is balanced. Now to find the answer, this is 60 plus, what is 60 into 2 is 120 plus half, that is 30. 120 plus 30 is 150. 60 plus 150 is equal to 75 times x, so x is equal to 210 upon 75. So I guess it will cancel out by 3 and 5 both. So 25 into, not 25, 5, 1, 2, 5, 15 and 5, 4, 1, 0, 2, 42, and then 3, it goes by 3 5 times, and it goes 3 by 1, 1, 2, 4, 14 by 5, that is, how much is that? 2.408, 2.8 meters. This, it would be your answer. In this case, we have been given a meter scale which is balanced at mark 60 centimeter by a weight of 10 grams suspended from one of its end. The question is, what is the weight of meter scale? Alright. Now, whatever the weight of meter scale, it will be at, now you will understand, it will be balanced at 50 centimeter, right? Because the center of mass, what is center of mass? Center of mass is the mass where whole mass of the body is supposed to be concentrated. That is the point. Basically, center of mass is a point where whole mass of the body is supposed to be concentrated. Now, it is not necessarily that center of mass lies inside the body or outside the body. It can lie anywhere. For example, consider a case of ring. A ring has a structure like this. So, center of mass is obviously going to point inside the ring, whereas not on any particular point on the body. So, this center of mass is a imaginary point in this case, whereas in case of disc, it will be at the center. So the point may lie or may lie outside the body. Now here the weight of the body is balanced by that 10 grams. So the weight, the clockwise moment or anti-clockwise moment times this distance, which is 10, is equal to 10 grams times this distance, which is 40. So 10 times 40. So we can cancel out 10. So we are going to get 40 grams. Now I have written weight is equal to 40 grams. Don't get confused with this term. This is mass of the scale and the weight would be mass times gravity. So yeah, you can formulate it any ways you like it.